Good evening, dear colleagues. You all are welcome to the 38th Energy Management Forum of Sri Lanka Energy Managers Association. The session for the year 2021-22 under new president, Mr. Tamila Jayasekara. Today, we are talking about benefits of precision machine alignment and power saving. We have two industry experts to share the subject knowledge. First is our known colleague, Mr. Saman Wijerathna, product of University of Peradeniya, specialized in industrial engineering and production engineer by profession with over 19 years industrial experience. The second is the expatriate, Mr. Sven Fleischer, is expert in vibration analyst and asset reliability production, and also the sales head of Easy Laser Asian region. Presentation will be 40 minutes, followed by 20 minutes Q&A session. You can raise any question in related to the presentation through Q&A or chat in the Zoom platform, which will be taken up during the Q&A session. Dear Saman and Mr. Sven, over to you to conduct the presentation. Thank you.
Thank you so much. Mr. Saman, I think you want to go ahead.
Yeah, Saman, you can start the presentation. Yes.
Okay. Thank you very much for giving this opportunity to me and Mr. Swin, given by the SLEMA Energy Forum address. So today our topic is proper alignment will be how impact of the reduce of carbon footprint and what are the advantages of doing this proper alignment. Actually, basically in Sri Lanka, the laser technology is using very minimum locations to do alignment purpose. So this is very highly impacted in our energy sector to increase in the energy consumption in the power transmission systems. If we are considering in the industry, basically mini hydro sector, the turbine and the flywheels mostly not basically alignment is problems. So that's why the heat coming out and bearing failures, those are happening due to the misalignment. So basically in our country practicing dial gauge method to align the main power transmission system. Other example is we consider some belt drive systems. We know if the belt the system is running when you enter to the factory, because the sound, that much of sound is coming out. That basically the sound noise is coming out due to misalignment problems. Our today presentation is how to do that proper alignment, the power transmission system, and what are the advantages of this. This is I introduced one of my business partner. Actually, he is the one of world famous person for the alignment sector, Mr. Swing. He is a Easy Laser business part of Asia Pacific region. He is the CAT3 certified vibration analysis and asset reliability practitioner. So I hand over to Mr. Singh to continue this technical presentation. Thank you. Mr. Singh.
Yeah, thank you so much, Mr. Saman, and thanks to everybody for having us today. It's a pleasure to be here, and I'm looking forward to discuss and upfront show you a couple of things in regards of precision laser alignment in association with the potential of saving energy. That's what the main topic is about. So the content of the presentation today is about machine operation and power transmission. We also have a very quick or briefly view into what actually means misalignment of machines, then consequently what means precision shaft alignment, the here connected power consumption and the potential of the energy savings, other associated cost factors which can be as a consequence of improper alignment at the machine be saved as well. 1-2 different studies in regards of those energy saving costs and other benefits in regards of precision machine shaft alignment. So I go ahead, precision laser shaft alignment, increase machine operation lifespan and reduce costs as a consequence as well. So first, what does this actually cost to operate a machine? To own a machine. You maybe will be surprised. The electrical energy consumption is the highest account in regards of cost factor for an asset over its operating and service life. So 70% of an ordinary machine, here we taking an example of a pump, is associated with the use of energy during the machine's fully life cycle. And it's quite high if you see all the other parts like purchase and other operating costs here related. What means shaft alignment actually? So we're talking about a rotating equipment that is connected to each other. So shaft rotational center lines aren't collinear at a point of power transfer when the machine is in operating condition. So whenever we're having this kind of condition, then the machine is misaligned. In operating condition means in a warm situation where the components, the machine parts have reached their operating temperature. So there's also something involved considered as temperature growth or thermal growth, especially when you think about gas and steam turbines. So the savings that can occur from precision alignment are often overlooked, while energy represents hundreds of thousands of dollars and the operation expenses in a whole plant. A significant portion of these costs are purely waste, because misalignment of coupled machine costs us valuable energy dollars. So precision alignment of machine shafts have proven to cut energy costs by as much as 10%. Now you would say for one machine, 10% energy could be, depend on the country, affordable, not expensive, but nevertheless 10% in time over year for many different machines can make a lot of money. Moreover, corrective misalignment condition also shorten the lifetime of the machine. It increases the machine failure. It causes the machine to stop. Potentially, you need to make a fully shutdown of the operation of a fully plant, and it reduces the product quality. So misalignment is expensive and it is unnecessary. What is misalignment? And we differentiate here between two main causes. The here ones shown angular misalignment. That is when the center of the two axes, so the shafts of our machines who are connected with each other, are not parallel to each other in operating condition. And the second is angular, an offset, or also called angular misalignment. And this is the case when the center lines of two axes are not concentrical, but they are parallel. And realistically, in the practice outside on a machine, you will find a combination of both. So angular and offset misalignment comes very often together. Now, if you think about consequences of misalignment and the physical motion of a rotating machine, I tried here to illustrate in a simple way referring to the bearings. So the bearings ensure the rotational movement through their construction to reduce the friction of the rotating shafts in its housing. So to eliminate and reduce the friction to a minimum, we are using bearings, and inside of these bearings we have a lubricant. This lubricant is found in a very thin gap between the two surfaces, so the raceway from inner race and outer race, and the rolling elements in between. Now, the thickness of this lubrication film is about 5 microns thick. So if you consider even a load zone and a small twist of the shaft that pushes the bearing to one side, as here indicated on this picture, we are creating stress. And 5 micron is actually not a lot. So therefore, we are creating in potential impact and stress component that damages subsurfaces in the structure of the bearing. And this kind of damage, you cannot see that in this stage, is generating and getting worse from time to time until the bearing is damaged. So all machines with an axial or radial driven connection need a correct installation and alignment to keep the lubricant film working, so that also the whole machine is available for a long time and at the end reliable. How do we recognize misalignment from an operating machine? Misalignment is the root cause of many machine breakdowns. Often technicians, floor shop people, engineers talk about the most occurring problem on rotating machineries are bearings that are failing. And it is correct, but there's a reason why this bearing is failing. Other cases, maybe seals are damaged, shafts and couplings. In fact, it is widely believed that 50% of all of the machine failures are due to a misalignment of the machine train or coupled machine. So precision alignment significantly increases the life of the machine. Misalignment itself leads into the form of stress and forces to the bearing. Misalignment can be very dangerous and also harmful. And again, it is actually expensive and unnecessary. Symptoms to recognize this machine shaft misalignment are, of course, temperature, because wherever you have friction as a consequence from some stresses, heat is developing. And further down, vibration occurs. So temperature and vibration are good indicator to assume that there is some stress, which is in the most cases related to a misalignment. But also shortened machine life is a symptom. Damaged bearings is a symptom. High machine vibration, of course, higher temperature, damaged coupling parts, oil leaks, etc. So we see here some picture from a thermography image from an operating machine with those hotspots of temperature indicated because there is some stress in this machine. We see measurement readings in ISO millimeter per second, so that is velocity unit of vibration in the machine. It's indicated red in alarm, so the vibration of the machine is too high. We see also BDU that is related to an indication in regards of vibration applied to a bearing. And G very often also as acceleration used as an unit to describe vibration in higher frequency, which applies to bearings. If you would do as a vibration specialist even in a more deeper analysis to diagnose, then it could be a frequency spectrum where then the order number 1, 2, in some cases even the third order are associated with symptoms the machine can have in regards of misalignment. So orders means fragments associated with the running speed of the machine times 2, times 3, etc. How to verify misalignment? Well, it's a very easy task if you have the equipment available. So perform laser shaft alignment with a precision of up to 1 micron, which is 1/1000th of a millimeter, to check and compare it to tolerances. So laser alignment instruments can have inbuilt those tolerances, which are based on the machine size and the speed. And then you can compare it. So Easy Laser, for example, in their alignment products have own tolerances, but we're using also global tolerances like the ANSI standard, American Norm for Standardization. And for some very special cases, also customer can create their own tolerances, so they are custom made. So an alignment check with a laser that represents once the shaft from the stationary machine and second from the machine that is possible to correct in its position called the movable machine. And this requires only a couple of minutes to check the condition of a machine. Now, we want to ensure that the machine is precisely aligned, and this starts actually on the foundation. So whenever we talk about precision and energy savings, we also assume that the basement, that the base or the frame structure of the machine is actually very flat. In some cases, it is even required that it have to be in a certain level. It should not have any soft foot problems, no looseness or runouts of parts of the machine itself. And then we can proceed to do the corrective action to align machines. And that means shafts, rotational center lines to bring collinear at their operating condition. And that's with a laser instrument very easy to achieve, pretty straightforward. Much faster than the traditional methods where you need to be highly skilled to use dial gauges, and it is way more accurate than that. Misalignment and the energy consumption. Before we coming to this point, I'd like to show you here on the slide what actually means precise shaft alignment. So while there are a number of factors to consider, the key issues when it comes to the relationship between misalignment and the damage that can be done to the machine is the machine speed. So if the speed of the machine is greater, also the damage potential to the machine is greater. So here we see in misalignment tolerance guide that gives us once the micron per millimeter, that is the deviation of the point of power transfer between the both shafts which are connected through the coupling. And on the right axis, we see the angle potential misalignment in degree. And on the x-axis, you can see the connected speed. So as higher the speed, as lower the allowed angle in angular misalignment or the deviation from the transmission in the center of the shaft. So just taking an example from 3000 RPM machine, actually permissible alignment condition of the machine in between excellent and acceptable is 0.8 micron per millimeter. That's then the diameter of the axis of power transfer. And that's pretty precise. And in laser alignment instrument can achieve an accuracy of 1 micron. So right where we need it. In regards of alignment is necessary, so where we're reaching the red area and say that's harmful for the machine, it's 1.2 micron for a machine that runs with 3000 RPM. Significant power savings can be made through an accurate and precise alignment. Here we show you soon findings that have been researched in a chemical plant, and they showed in average that 93% of all of their rotating machineries are outside of the tolerances that we just have seen. So tolerances exist on the market to compare to. Precision alignment reduces energy consumption, and this reduces energy costs. The energy consumption has the greatest potential to reduce costs among all of the machine life related factors. We're coming soon to a couple of examples. This is the potential that we earlier said in another slide. You can actually save up to 10% quite easily when your machines are in a precision alignment condition. So precise machine alignment eliminates the reaction forces and reduces the energy consumption by up to 10%. So this is a completely independent study from a university that shows a misalignment condition of 1.6 millimeter compared to 0.2 up to 0 millimeter. And what is the energy consumption here in comparison? So we're reaching between 0 to 12%, 10%. So this is really the potential of saving energy. Now, an own study that we have done in addition is here an example where we're having a pump with 75 kilowatt that operates maybe only with 8 hours per day, not every day. So we choose 300. And we are reducing here in 1 millimeter offset through a precise alignment to a 0.2 millimeter. So 0.2 millimeter is still not very precise, but alone this change from 1 millimeter down to 0.2 millimeter in a calculation of the energy consumption means that it can easily save you 48 euro per year. Sorry, it can easily save you 714 euro per year. If you would make it even more precise, so instead of 0.2 going down to 0.05 millimeter, then there's an additional potential of saving costs of $48. So altogether, 750 euro, not dollar, I'm sorry for my mistake, is the energy saving here per year for this machine that has initially had a misalignment of 1 millimeter and precisely aligned to 0.05 millimeter. Other costs here are associated with precision shaft alignment. Again, we're coming back to the bearing because they are very crucial. And they are also the components that suffer the most are from an existing misalignment. So misalignment puts unnecessary load and forces on the bearing. All the experts and many researchers worldwide have proven, and all of the experts are agree, that actually less than 10% of all operating machines, and here related the bearings, reaching their designed lifetime. That means they fail before they are doing the specified work. And this is due to many causes. One of them, and contributes to 50%, is misalignment. Here's again another study also from a university that shows the difference between an offset misalignment of 1 millimeter versus 0.2 millimeter. And this has shown that the lifetime of the bearing can here increase by 50%. So if we are taking away the stress, as this graphic shows, from our rolling elements inside of the bearing, we extend therefore the lifetime of the bearing. And this is a consequence of a precision alignment of the machine. Let's go into the mechanical seal. So that's actually the part that quite often is first damaged and then the lubricant is leaking. So here we see the difference also in offset misalignment, but from 1.2 millimeter versus 0.05 millimeter. And this can extend the mechanical seal life by many months. So we have here 2 months in regards of 1.2 millimeter and up to 19 months of operation when we are talking about a machine that has a misalignment offset from only 0.05 millimeter. In study that have been done, so sorry for the long text and the numbers, but that is what energy or cost savings is about. In study has shown here that tests on smaller pumps, the current that is there drawn was by a motor 12.2 amps. After being realigned, the current have been put down to 11.8 amps, which is in difference of 3.28%. If we are a little bit conservative here and say, well, we're not taking this 3%, we actually go only down to 1%, then the energy saving costs per year for this one machine is 107 euro. But 1% versus 10%, so you can maybe see or understand what is the potential between a precise aligned machine and in a machine that has a misalignment. Now, the plant has here, so that's not something Easy Laser has done, in completely independent party, researched a couple of machines. So there were 30 pumps, 5 fans, 4 compressors. This is a mixture from their power consumption, and all of them have been monitored over a long time. That was back in 2002. So those machines have been operated 24/7, and the difference between misalignment initial stage and the stage where all of this machine have been aligned with a higher precision according to the tolerances are actually in regards of the percentage and energy saving altogether per year 4,348 euro. And this is just for 39 machines. Now, this is something which you can easily achieve with a precision laser alignment equipment, because laser is capable of measuring with a much higher precision compared to dial gauges. Completely independent from the event, that's way more convenient to do that and has additional advantages. So 4,000 euro very easily saved from not even 40 machines. Another study here, secondary plant, it's same related study, but another part of cost. So the same machine have been here investigated in regards of the MTBF. So the mean time between failure is in kind of time interval that is recorded from the maintenance and reliability teams, how often a machine shows failure to need to be maintained, to need to be repaired. So aligning machines within straight edge, not even within dial gauge, so the same 39 machines, results in an MTBF interval of 6 months. So we're taking here the average cost per machine, 344 euro, and all them together for all of this machine came to a summary of 26,000 euro. Now the same machines aligned with a laser instrument removes the stress, the alignment condition is inside of the required tolerances. As a consequence, the machine is not failing that often. So the time interval between a potential repair and the next one is here largely increased to average 20 months compared to 6 months as a consequence. We're having here now yearly savings from up to $18,800 just for the repair costs itself, which includes spare parts, etc. If you think about the same costs for the technician and engineers who are carrying out those repairs, then we come in this equation even further down to a point of saving 1,248 euro more. So now putting all of these numbers together from 39 machines only. So here the bare minimum that would have been saved in the secondary plant, the electricity savings could be up to 3 times higher, since we have here chosen only the improved energy saving of 3.28%. 10 is theoretically possible, but for this purpose here we're using actually only 1%. So therefore the electricity savings are 4,384 euro. The labor costs, which we had in the previous slide, was 1,200 euro, and the repair costs 3,800. So altogether, we could have saved here easily 10,000 euro just in a difference from 39 machines that have been aligned with a laser alignment instrument compared to straight edge. But this is not even the tip of the potential savings that can be achieved when we talk about a precision laser alignment. In summary, machines like pumps, etc., with speed about 3,000 RPM or more. The tests that have been here done was in a chemical plant, and to just repeat this information, only 8% of their machines are actually inside of acceptable alignment tolerances. So aligning them in a precision mode can save us up to 10% of the power consumption, can reduce costs in regards of bearings and seals by more than 60%. The repairs for the pumps have been declined in the study by more than 25%. And the lifetime of this machine has improved, increased, so it can be utilized fully and beyond. So there's a lot of saving potential in an operating machine when we talk about precision alignment. To summarize, benefits of precision machine alignment: increased lifetime from operating machines, reduced costs of spare parts, bearings, mechanical seals, reduced maintenance and labor costs, and improved planning. So those maintenance engineers getting then more time to do different tasks and jobs, maybe inside of a condition monitoring program or aligning other machines. Reduced costs on brackets and documentation issues. That is in regards of comparing laser alignment with dial gauges, where you need to have many different brackets, and even if you would apply it, then you still have this kind of evidence need. You need to write a protocol by hand. A laser instrument generates the report on the instrument itself, sends it out via email to a manager, a supervisor, or a customer. Other benefits are improved plant operation and reliability, increased plant availability, reducing power consumption at the plant, improved plant operating safety, and you would have a contribution to a cleaner environment. 5 reasons to align your machines. Machine alignments is one of the best improvements you can make for the environment. So there, of course, always something that can be done better. And if you are scaling it down to the value of potential improvement, the precision alignment is really showing us the highest potential to improve the operation of the machine and reducing costs. Having here proper alignment makes production more efficient and helps to minimize waste. An alignment system will improve your working environment. correctly aligned machine reduce the risks of extensive breakdowns. So that is a factor which we have not actually calculated into those previous examples. What happens with a machine that breaks down, that stops basically your plant, your operation from operating or producing? This is actually the highest cost factor. So if you are increasing the mean time between failures of this machine, you are having there even a much higher potential of saving costs. You will gain more than you first thought, just through precision alignment of the machines. We recommend here a certain step-by-step procedure in regards of alignment. So there are some checks to do before actually correcting the physical position of a machine. Safety always first, clean. We deal with shims and corrective measures to do that really in a good way. There are a few preparations here under point number 1. Point number 2 is kind of rough alignment to make sure also that all of the balls are tightened. You remember I said no loose parts, no hold down balls and things like this. Number 3 is setting up the laser instrument. So to put the brackets on the shafts and adjusting them initially. And then you can achieve very easy on this position already in alignment condition that is smaller than 0.5 millimeter. And then your real physical position alignment starts, where also the soft foot of the machine is checked, which you can then achieve an alignment condition of 0.05 millimeter very easily. Check it, verify the results after the machine correction has been proceeded. So the instrument tells you how to align the machine. Save the file for later, so you can use it in maybe 2 years again on the same machine. And the instrument provides you a report with all of the details that you can send to customer, to your operator or supervisor. If you're interested, I'm sure that this forum can potentially share this presentation later. So you find on our Easy Laser website all of those kind of articles that are here shown as an web link in regards of justification from doing laser shaft alignment. So what are the benefits? Why are so many operating maintenance departments actually doing that? Then there are large savings when it comes to sheave and pulley driven machines. Proper alignment will reduce your carbon footprint, so that's something that we have explained today, and many other different hidden opportunities to make savings. Thank you so much for your patience. We have now reached the Q&A section.
Yeah, thank you very much, Mr. Saman Wijerathna.
Most welcome.
Now we come to the Q&A session. Yeah, dear colleagues, you can raise any questions related to the presentation through Q&A or chat. I will take it up with the Senno and Mr. Saman.
Yeah, first time here. Any questions regarding the laser alignment, vibration analysis, and balancing? Any questions from audience? We are here, and Mr. Swin can answer, or myself, I can answer for those questions.
Hello, Saman. This is Amila. Can you hear?
Yeah, Amila, I can hear.
Thank you, Saman, for introducing Mr. Swin to us. And this is exactly what we wanted from Energy Forums, because these are new technologies which we are not using at the moment when we are conducting energy audits. Myself, being an electrical engineer, of course, has very limited knowledge on alignments. But I have a few questions as an energy auditor. Say we conduct audits at different scales. So first step of our audits would be to go to a site and identify potential areas for further analysis, measurements, and so on. This is through the walkthrough survey. So when we go to a new site, of course, I understood that there is a lot of potential in aligning a big machine. But at what scale should we be really concerned about machine alignments? Is it applicable even for very small machines, or can you guide us on what level of or what size of machines should we look at as to, you know, being a potential energy saving area? Because if it is a small machine, maybe asking the client to do an alignment may not be really worthwhile. So that is my first question. Hope I could ask two more questions when I got the chance.
Okay. Yeah, I mean, first explain by myself and
Okay.
then plan. Actually, for the very small machines, power loss is very small. But if it is consider the 5 kilowatt above, actually, I
Okay.
have demonstrate unit do this the demonstration of power loss from the motors. I have
Mhm.
demonstrate unit. We study on that less than 5 kilowatt motors. The waste is there, but uh, energy cost is less. Therefore, the losses, but other main failure is if there's a no proper alignment, bearing failure is the main impact. So considering the cost factors less than 5 kilowatt motors, the bearing replacement cost is the higher than the energy losses. So if we are considering the size above 5 kilowatt motors, having all equipment, do proper alignment, can take big amount. Actually, 10% of energy cost reduction can prove by uh, proper alignment. Actually, in Sri Lankan practice, we are not using even sims to level the motors. Just put a concrete and a 4 bolt, put a motor and put a pump in other side, put a dial gauge and do some roughly alignment. That's all we are doing. That is the reason to failure of bearing every time in our motors. Right, better when we are do the energy auditing, actually we have to get the vibration measurement on both side of the transmission of power, and we can analyze is there any misalignment or is there any bearing failures. So that profile can take the how much energy can save from this doing the better alignment, precision alignment. uh, Amila is okay with me. Srin, anything you can tell regarding this?
It's a quite a reasonable but also tricky question. Out of question, it is a complicated thing to say. Where do we have the most potential of saving energy? And if you pinpoint it only to one machine, well, that's something you have to make a decision. But you need to bring it into a context to consider hundreds of machines. And this comes with a criticality analysis. And in regards of to prove also the potential of energy saving, I would meet somewhere in the middle range. So everything maybe 15 kilowatt and higher, but that's maybe in regards of getting your feet wet to prove the alignment that can be easily achieved with the correct instrument, and what would be the energy saving. Because a small machine with very little weight, you could have difficulties to prove, because if you're not used to use in laser alignment instrument, it could be tricky. So very small and very large machine are easier to tackle when you have a bit experience. So just for the proof of the concept and to realize what kind of potential this precision laser shaft alignment could have, maybe start with average machines, a motor pump combination for medium size, motor fan combination, etc. But this is just a topic about energy savings, as Mr. Saman explained. Not really the size of the machine is important to consider about what effects the fail of the machine could have. The smallest machine can be more important than the largest one, depend on what kind of operation this machine is built for. So it starts also like the ISO defines with a criticality analysis to look into an operation into a plant, and as said, in check of the condition of the machine can be easily done with a couple of minutes. Of course, the machine needs to be non-operating. If you think about our operating machines, then you find easily all kinds of symptoms to know which machine has likely a misalignment problem. And I would start on this point, not so much stick on the size, but this is really an energy saving potential that goes across in an average calculation from small, medium, and very large machines.
Okay, thanks, Mr. Mr. Amile. Sorry, Dr. Amile, any questions from your side? Second question.
Yeah, Saman, Prasanna has raised one question.
Yeah.
Can you give cost-related factors for alignment and can use it vehicles? That means he is relating misalignment in vehicles, related cost savings like.
Actually, this is the vehicle, the wheel alignment and the balancing is also impact to our running cost. If there's a misalignment, tire waste is the main issues, and also it will impact to our fuel consumption also. But exactly, I don't know regarding this. I didn't do any study regarding the vehicles. I did only the basically to misalignment issue with the power consumption for the machineries. So this is basically understanding of this misalignment is impact to the tire waste of the vehicle. Fuel, we are not did any survey on this. Actually, this is a good topic also. I also think about it to do it later. Prasanna, is it enough for your questions? Answer is enough for your questions? Okay.
Okay, thanks. Yes. Yeah.
Rasika, can I shoot the second question?
Yes, of course.
Okay,
Yes.
Doctor.
Actually, you two actually touched upon this during your first explanation, and the first explanation, thank you very much. 5 to 15, I think, is a good area. Of course, I understand, there's no hard and fast rule, but just to have a feel of, where we should actually look at alignment as a potential area, I think that's a good guide. But say for a preliminary study, if we suspect that there is a big machine and there could be a potential for energy saving through proper alignment, is there a way to kind of detect a misalignment without having precision instruments in hand before we engage an expert for an energy auditor to do a preliminary identification of the issue? Are there kind of makeshift instruments like a thermal imaging or something like that? Can you
Yeah, Dr. Amila, actually the first indicator is that thermal image. We can get the thermal image, and if there any heat, unconditioned heat coming up from the both side of the bearings, then we can identify is there any problems. Heat problem is coming, generally misalignment, right? Second things we can do, we have the equipment called vibration analyzer. This is a simple equipment we have. Just we can monitor is there vibration, the level we can identify. Use a very small unit we have, right? So we put that unit, then we can get a profile on the vibration pattern. Then if you know the pattern, then we can identify is there any misalignment or not. So that is basically we can have, but that equipment has to be used.
So
because
how much,
this is a
generally, how
precision
much would that
alignment.
cost?
Yeah,
The
we are talking
instrument,
about the
is it an
precision
expensive
alignment.
one?
Actually, this is prices is starting from 3,50,000 to 40 lakhs something. I have that equipment range. I have that smaller one also, so that's why I'm telling prices. That is starting from 3 to 4 lakhs. Just a vibration analysis, smaller one, right? Then.
Okay.
Yeah.
Thank you, Saman. Great to know that you have the instrument as well.
Yeah. Actually, in Sri Lanka, all the instrument that the vibration analysis, the precision alignment, leveling, I have that equipment set. I do business also with the outside, especially in waterboard projects. Few waterboard projects in Biagama, new water farm fixing. Now these days we are doing the project on Polgahavila new water projects. So basically we are dealing with the Indian parties. They are the contractors, no? They are hiring us for this leveling and the precision alignment part.
If you allow me to contribute, sorry, Mr. Saman.
Yeah.
Just if you allow me to contribute, it is indeed a tricky part to make a root cause analysis on a machine that is under operation. And as we say, stresses are creating a temperature. So you have an infrared picture that can just tell you, hey, there is something, but you have not much chances on this point to verify which is the root cause exactly. Is it an unbalance? Is it a misalignment? Is it a lubrication issue or something else? So vibration analysis, and this applies on rotating machine, can very easily be applied. You need to have an equipment and a bit understanding, either through the equipment or the engineer who is doing it, to do a quick frequency spectrum. And this, together with the knowledge of the design of the machine and the speed, allows you to quickly verify between all the problems the machine could have, or the root causes the machine could generate symptoms like heat, etc. And this is unbalanced, misalignment, bearing damage, looseness, and so on. So for those ones who are acting in vibration monitoring equipment, it can be very easily verified and specified, but that requires some kind of measurement technology.
Okay, thank you very much. Thank you. It's really helpful. Thanks.
Most welcome.
Any further question from audience?
Maybe one question that comes in my mind, that comes very often in similar meetings, is from the audience to ask what kind of measurement range between, those two measurement heads we are using on both ends of the machine can be, because the size of the machine is obviously something that is important. So we're having equipment that can measure, excuse me, for shaft alignment up to 20 meters. I say, what is 20 meters? I have to think about cooling tower, where you have a spacer shaft in between motor and gearbox. 20 meters can be easily achieved. And we measure then in this range still with accuracy with this laser and detector of 1 micron. So all kind of designs of brackets exists to bypass obstacle, and different measurement methods can be applied, depend on the machine, can the shaft rotate, is it uncoupled, and so on. So there are a lot of ways to apply laser alignment equipment.
And I have a third question as very sorry if I'm taking most of the time. But the last question, I think you barely touch on it, but what are the typical machines we would find in the Sri Lankan context, because we don't have that large manufacturing processes. Typical equipment of machinery we should be looking at. One, you mentioned that pumps, water pumps and so on would be compressors.
Actually,
or where else should we look at when we are conducting audits? What are the typical machines which would have potential for alignment, savings?
Yeah, actually, Dr. Amila, this is we have to practice especially in the water pump sector, water pump and the motor sector. Other sector is that mini hydro sector. Actually, we are touching this section also currently now. And the cement industry, there's a lot of heavy machineries they are using. They are now moving to this technology, but not fully. And also in the crusher industry, this is a metal crushers. This is around area we have a lot of crushers, but you can see the noise of they are not doing any alignment. This is in the ground level to fix the machine. We have to do alignment on these machineries. Other is the steel industry. There's a lot of steel industry running in Sri Lanka. The metal making and the processing of blank. They are also now this the line is there for making some either box bar or a rope. They are making lines, but that line is not aligned. Basically, that is wasting huge amount of energy. Actually, I am touching some areas, but not fully. I found those area in the Sri Lanka. Basically, what about we did some audit in the what is called not Biagam, other side, Ambatale, but they are also, I remember there is a lot of machines having that issue. But in the other side, Ambatale other side is a Biagama one, they are functioning of this. Actually, I work with that people. They did the proper alignment before fixing the machineries at the new project. This is the Amila. Now we have to touch on that area. Heavy machinery is using in the now we are working with the Pirimal glass and plywood organization in close by and paper industry. We are touching with those industries. We are working with them also. Actually, there is a lot of potential to do energy saving on this area. Okay, Amila?
Yes,
Dr.
yes.
Amila?
Thank you very much. Yes, thank you.
Okay, thank you, Amila.
Yeah. Saman, I think the printing industry also another industry to be look at, no? That printing, there are heavy motors and
a lot of the alignment must be there in the printing industry. Yes. Actually, I visited the factory called the previously paper industry in Homagam area, just past the Homagam. Ceylon Printing Corporation, no? This all machine is there, but they also not practicing anything regarding this kind of technology.
Maybe this is something to also contribute quickly something. So whenever we talk about pulp and paper printing, we very often have outboard machines that drive those rollers with cardan shafts, so with joint shafts to compensate an offset. So also this is something that needs to be actually precisely aligned. So many operator or technician think, hey, I have a cardan shaft which has this joint in between the spacing shaft. They can take misalignment. No, that's completely wrong. Also, those machines with an offset in position need to be precise aligned. Because if not, then they are generating the same stress on the bearings. As a consequence, the motor takes more energy to establish the required speed.
Yeah. Thank you, Sven. Saman, Saman, is good news for us to know that you are having vibration analysis.
Yeah, actually, I have business on this vibration analysis, laser alignment and precision leveling, and also thermal imaging. Actually, condition-based monitoring we do as our business.
Okay. Now, if no more questions, then now we are winding up the forum, Energy Management Forum from here. Actually, Mr. Sven, Mr. Saman, thank you very much